We are Team NeuroAct, and we are working with a startup that creates a wearable armband with electromyography technology. This technology lets users interact with the computer applications by detecting the neural signals produced by the hand muscles. Our goal is to find the potential use cases for the armband in the span of 16 weeks, while troubleshooting any technical errors that occur during the process. Because the device is still at its early development stage, it faces several challenges regarding to the hardware and the network communication. Therefore, it was very important for me as a producer to scope the design process, set weekly sprints for trials and errors, facilitate the coordination between teammates, and manage our schedule to plan ahead for any problems that could arise. We are very proud of what we have achieved for our clients, and we hope that other developers could learn from our experience to develop better applications for this cutting-edge technology.
The most interesting part of this project is how machine learning combining with human interaction. When implementing machine learning algorithm, we more care about the neural network architecture and how different layer design and tricks affect the performance. However, when it comes to scenarios dealing with real people, things get complicated. Because the model is learning the human interaction, human is also learning to adapt to the model prediction at the same time. So in technical perspective, the ultimate goal of this project is to find the trade-off to make machine learning model and the human interaction converge to the same point efficiently and stably.
The key to making a great user experience for this armband with active control depends on how comfortable and natural the interactions are to the users. Since the player needs to understand the correlation between their gestures and what's happening on the screen, so it's quite important for us to convey to the players that what gesture they need to use, when to do it, and if their gesture detection is successful or not. And in this project, we focus on three important factors: ease of training, ease of control, and ergonomics. For example, in snowboarding game, I iterated the interface from graphic user interface to the natural user interface, which allows the user to define their own gestures. And we also embedded the training within the gameplay. In this way, the gesture could be refined during the entire experience. And I also encourage them to do shuttle finger movements so that they will not get muscle tensions.
Throughout the semester, we did playtesting with a variety of users and had some observations. Through playtesting, we found that players intended to do exaggerated gestures, and we used props to encourage them to use smaller gestures. We found that giving visual and audio feedback when the users are doing the correct thing is the key to help users build up confidence in using the device. For example, in the cake making game, I worked on creating particle system of cream so that the user can get instant feedback when they squeeze. We realized that this connection between player gestures and on-screen events would reduce the fun of the play, and we added helper control at the beginning of training so that users will stick to the one gesture. We also realized that users who have little experience with novel technology would need explicit instruction to tell them what to do. Therefore, we added text instructions and audio instructions back in our later prototypes.
Since our client wanted us to explore a combination of technologies and new experiences, we made a music synthesizer using the Kinect and the armband in Cake. While other experiences were built in Unity, we wanted to use the web-based platform as it allowed us to explore real-time visualization and audio modification. Our client provided an SDK that communicates with the Unity and the device. So I implemented a WebSocket bridge for the device and used Node.js for the Kinect to run the application on the browser. We as a team learned quite a lot about rapid prototyping and designing for innovative interfaces like these. It has been a crazy but interesting experience so far working with this futuristic technology.
With this new type of input device, we wanted to explore the possibility of creative expression other than games. So we came up with an idea of interactive sound synthesizer, which creates an immersive experience by giving users audio and visual feedback in Cake. In the 3-minute experience, we tried to implement the micro-gesture detection with armband and position tracking with Kinect, which also shows the potentiality of combination with other devices. I designed sound layers which are played based on users' position and mapped users' gesture to the cutoff frequency and resonance of low-pass filter. For the visualization, I tried the mosaic-style video captured image, and it enhances the immersiveness of the space. Even though each step we ran into wasn't always easy, we are really happy that we had a chance to contribute and dig deeper into the possibility of awesome technology.
Podcast.